We've all been perplexed by the decisions made by teens in our lives. Can neuroscience explain this? Welcome to ReachMD Book Club. I'm your host, Dr. John Russell, and we're joined by Dr. Frances Jensen, author of the book, The Teenage Brain, a Neuroscientist's Survival Guide to Raising Adolescents and Young Adults. Dr. Jensen, welcome to the show.
Thanks for having me here.
So how did this book come about?
Oh, well, I'm a neurologist, but I also do brain research. So I do some neurodevelopmental research. And I was happily doing my combination of my research and my clinical work. And then, of course, I had two sons who metamorphed into something I couldn't quite understand during their early teenage years. And I decided to turn sort of what could have been frustration, sometimes anger, into curiosity. And given I was in the field, I was like, what is going on in their brains? Really smart kids doing really stupid things at times. How does that happen? There's got to be better research about this. So I started to really look into the research. Because I was working in developmental neurobiology in my lab, I had an experiment going on at home, which were these kids. And so I started to look into it and really learned that there are a lot of myths that need to be debunked. There's a lot of great new facts that are only since about the mid-2000s that are available for people to think about and actually apply to their lives and their opportunities for their teenagers and adolescents. And I learned, of course, that the brain is the last organ in the body to mature, and it doesn't finish until your mid-20s. So this whole thing kind of kept going. I kept answering questions for teachers, and I was trying to explain my own kids. I was trying to defend my own kids to teachers, and one thing led to another. I started to do Teen Brain 101 talks at their high schools, and then I went to the Science Museum, and I started to write about it, and I thought, this is a book.
It's a terrific book. As a parent of three, not yet 20-year-olds, it's really an amazing book. So in general, how would you say the teenage brain is different?
So in two or three really important ways. As I said, these teenagers, especially as they hit mid-teen years, they start to look like adults, and they're given a lot of license in our society to be in the adult world, yet they really are only about 80% of the way there in terms of a lot of different factors in brain development. Some very important facts. One is they actually have an edge on us as adults and for themselves in the future in their ability to learn, and for their synapses, of course, where neurons are connecting and communicating with each other, their synapses are actually, they have more synapses than they will as adults. Children have the most, and then it's sort of coming down to adult levels. So kids that are in their teen years actually have more synapses and more ability to mold their synapses to experience. We call this synaptic plasticity. It's a term some people in the medical profession probably know. And they're going through this period where learning is a form of synaptic plasticity. So as you learn, you're building larger synapses in the pathway where the learning is taking place. And they can do this faster and stronger and harder and longer than we can. That's a real plus for them to know about. There's a downside about that I can talk about in a minute. The other part of the teen brain, though, while they're all kind of revved up with this very excitable brain and very impressionable and rapidly learning brain, the way the different lobes of the brain are actually connected to each other through tracks is not at all complete. And this process, which you know is myelination, we have myelin which insulates the nerve fibers, is a process which takes a very long time to finish. And it starts in the back of your brain, brainstem, and back of your brain, moves forward. And of course, the last place to have fully myelinated connections is, guess what, the frontal lobe. And just knowing this as a parent and even as a physician, I took care of a lot of adolescents when I was back up in Boston. I was seeing both pediatric and adult neurology. They're not compliant, they do this, they do that. Even as a physician, I'm like, thank you. It's not that they're really necessarily doing it on purpose, but they aren't using their frontal lobes because guess what? They're not really hooked up yet, and they're the last places where the myelination completes. So what happens is because your frontal lobes are your seat of your executive function, impulse control, judgment, insight, empathy, these are all things I would say that teenagers have a ways to go on. So those are big stories, I think, and very important for caregivers, teachers, parents, and the teens themselves to understand that they're not there yet, and we can hold them accountable only probably so far. And that's why I kind of have been saying we are parents, and they are officially still dependents until 18. They're not done at 18, but they're further along than they are at 14 and 15. So as a parent or even a physician, a psychologist, counselor, teacher, you do have your frontal lobes attached, and you kind of have to use them for these teenagers and sort of help explain explicitly why cause and effect, issues around judgment and impulse control that they're so vulnerable to.
And even it's funny you kind of wrote about society has dictated these different age marks for different things. I can drive at 16, I can buy I could buy cigarettes, or I could vote at 18. I can 21 to have a drink, I guess in most states, 25 to rent a car. It seems very arbitrary, right?
It does. And they aren't allowed to drink, but we are happy to put them out on the front line in the battlefield, right? Because they're impulsive and they don't think twice. That's what you want out of the front line. So, society had known this for a long time. But, of course, the car insurance group has known this too. They know, what's in a 16-year-old's brain. They just didn't know the real neurobiology. They were more, seeing the outside. But the point is that there's a lot of strengths and vulnerabilities of this, to be serious about this. And I put this in the book. So the book has actually a lot of basic science made readable. I actually even have figures from some real papers, because if we're lucky, some of this will actually get to the teenager. And if you are an adult trying to explain something to a teenager, they respect data. They will not do something because a physician or a parent says or a teacher says, you do this. They're going to say why. And it's not, you can't say because I tell you. You can say, well, this study showed, there is information that. And I found, and the parents that I've worked with and the teachers have found it actually quite helpful to have this. It certainly takes the panic away of like, what the hell is going on with my kid, or why is this adolescent patient not doing? It helps you understand that there's neurobiology behind it.
I think the first thing, and really this book should really be on the desk of every school superintendent, is talking about sleep. I've seen so many parents who brought in a kid, he sleeps all the time. He sleeps all the time on the weekend. Does he have some horrible disease, and he has teenagehood, right?
Right. He's trying to catch up for the induced sleep deprivation that our day-to-day lives, our school schedule results in. I mean, their circadian clock is actually offset by 2 to 3 hours compared to the adult. And so what happens, and this is in every species actually, it's in all mammals do this. So your melatonin, which is, a trigger to go to sleep, is actually released a couple of hours later in teenagers. So they're not getting that until 11 o'clock at night or later, whereas we adults, we're falling flat on our faces about 9. It's happening earlier. But, of course, we're waking them up at 6 to get on a school bus. It's like waking an adult up at 3 a.m. Yeah. Worse yet, we give them the SATs at 7:30 with, arrive with sharpened pencils and get to work, and their brains are not necessarily functioning so well. So they're playing catch-up over the weekend for the sleep deprivation that we induce. They're not necessarily being slovenly or, trying to be annoying by sleeping in.
Yeah, we have 6-year-olds who are up at 5 in the morning, and they go off to school at kind of 9:30 or 10. You're listening to ReachMD Book Club. I'm your host, Dr. John Russell, and we're being joined by Dr. Frances Jensen, author of The Teenage Brain. So have some schools kind of looked into starting their days later and kind of shifting some of that for teenagers?
There are some schools that are starting to do that. I know in one of my kids' schools, what they did was during exam week, they started the exams at 10 a.m. So at least the kids, had some time to sort of get themselves to where they needed to be. Now, interestingly, sleep deprivation actually affects learning. There are studies that show that sleep-deprived brains from animals and humans do not learn as well. And also that sleep has a way of consolidating memory. So we're actually doing a couple of things simultaneously that are counterproductive to teenagers. We're making them wake up and get off cycle. We are not giving them the amount of sleep that they need to consolidate their memories. And also the fact that they are sleep-deprived impairs their learning.
So one of the things with teenagers, they often seem to have a very impulsive thing to do something very stupid. I'm going to shave my head. I'm going to do this. I'm going to do that. Can you explain that from a neuroscience level, kind of the foolishness in kids who otherwise are smart, good kids?
Exactly. So judgment, insight, control, impulse control are all things that the frontal lobe really dictates. So they do not have fully myelinated tracts to their frontal lobes. Their connections to their frontal lobes are not insulated for fast transmission. They have their frontal lobes. They will reason through things on an SAT test slowly, but split second, they're not going to have that, millisecond transmission going from one part of the brain to the other to go, you know what? I have to put the brake on now. I'm at a stoplight, and I'm not going to go through it. They're not going to do that because they just don't. They're not going to, in the moment, be able to do that as much. Couple that with the fact that their emotional area of their brain, their limbic system, is actually all, because it's further back in the brain, is actually fully myelinated and raring to go. So they have a very high emotional response range. At the same time, they don't have what we have as adults, which is a frontal lobe that dampens down these exuberant, rather labile responses. Yeah. Like they got a lot of rev in their emotion centers of their brain and not enough impulse control in their front. So this can be the perfect storm, as many people have said, for impulsive behavior going wrong.
So all those bad substances we want our adult patients to stay away from, tobacco and alcohol, marijuana, etc., seems to be really even that much worse to an adolescent brain, correct?
Yes, I'm glad you asked that question. So first of all, let's just say that we know they're more impulsive, right, for the reasons I've just said. So they're going to be much more tempted to go, oh, I'm going to just try that. My friends are doing that. I'm going to try Molly. You know, everybody looks like they're having a good time. Not like somebody's told me that's not a good idea. That little voice, which is your frontal lobe, is not very loud. So they're going to get themselves into these situations, which could include addictability, you know, substances of abuse, toxic substances. It turns out, remember I said they learn better. So they have better synaptic plasticity, which means with repeated use, a synapse, a connection between two neurons, the more it's used, the larger it gets. That's actually how we remember. The basic biology, which I explained in the book, synaptic plasticity, something called long-term potentiation, meaning long-term potentiation strengthening of a synapse, takes place because when that synapse is activated, calcium comes in, turns on a lot of proteins that help build, that send up and like build more synapse area. So that's how it happens. Now, they have more of those proteins. They're developmentally programmed, as are children. Children are even more, actually, during what we call the critical period of development, where they can, you know, learn 2 and 3 languages flawlessly. It just is like by osmosis. The reason that is, they're so lucky. They have this, you know, all these proteins just, they're up at higher levels, just sitting there at the synapse, so they can build synapses so much faster. So that's good for learning, but guess what? Good things can change synapses, and so can bad things. So unfortunately, for instance, while teenagers learn better, they can get addicted better. Why? Addiction is simply a form of learning. It's just in a different circuit. It's in the reward circuits in your brain. So actually, what happens is it's been shown that, you know, you learn, you have signaling going across the synapse. They can learn stronger, longer, faster than an adult. Memory games don't ever play against your teenager because they will win for that reason. But at the same time, unfortunately, repeated stimulation, this time by a drug, over and over again builds a stronger yearning and reward. And that long-term potentiation, which is happening in the dopamine system, in the reward centers of your brain, actually causes teenagers to be addicted harder, stronger, longer, faster than adults, just like they can learn harder, stronger, longer, faster. So that to me was a huge like awakening moment that I felt needed to get out there, really get out there. And it suggests that teenagers are more vulnerable. They have more synapses. Most of these drugs work at synapses. It's not, you know, rocket science to think about the fact that it's actually going to affect them more than an adult. For instance, alcohol, binge drinking, for the same amount of alcohol content in the blood, the teenage brain can actually undergo damage, whereas an adult just might get intoxicated and sedated and fall asleep. There's actual damage potentially going on in the teen brain. Another substance like this is Molly, which is ecstasy, MDMA, very popular party drug. And we know at Wesleyan College, for instance, they announced 12 kids who had been hospitalized. It was a bad batch, but nevertheless, these very, very, very smart kids are experimenting with drugs that can actually damage their brains. And in fact, a young adult or teenager, their brain, because of their receptors, it's more susceptible to the damaging effects of Molly, which are unpredictable, than the adult.
So, and there's so many other great things in the book, and I would really recommend it to anyone who's got teenagers at home, anyone who's doing primary care, neurology, because there's so many other things like, you know, concussions and stress and things like that. If you had to sum up a couple tips that you would give to someone who has young people in their life on how to navigate living with these folks whose brains haven't developed, what would some of those recommendations be?
Yeah, well, first of all, while a lot of what we've just talked about in the last few minutes has been like, oh, you know, bad things. There's really good things that happen in the teen brain. So there's evidence and real data that has shown that your IQ can change during your teen years. We all thought it was a fixed number, but a third of people's IQ does stay the same. A third goes up, a third goes down. So there are reasons for this that are written into the book, but it's a time of hope and an ability for people to really turn their time around, which gets me to sort of the major points I'd like to make, that it's a very amazing time in development that parents and teachers need to sort of step back and recognize, and teenagers themselves, that this is an opportunity time. This is a time where they can build their brain for later, but that everything that's happening to them, be it stress, be it sleep deprivation, substance abuse, is actually affecting the way their brain's going to be for the rest of their lives. So to really take the good and the bad, and recognize it's a very precious time. It's kind of like a second critical period for the brain, and that it's not done yet. It's not even done at the beginning of college. It's not even done at the end of the college. It's getting there. So that's important. I would say to use information to make you sort of stop and be a little bit more patient as a caregiver or a parent or a teacher, rather than reacting and letting your own anger. Some of this is not really as intentional as you think. Some is, but some isn't. So I would say count to 10, be a little bit more patient, and also stay connected, because as you know, as a physician, this is a time where you need to kind of know what's going on in the lives of these kids. It turns out that mental illness really does blossom forth at the end of the teen years into the early 20s. And there's a reason for that. For instance, schizophrenia, which classically comes on late teens, early 20s, you need your frontal lobe hooked up to do schizophrenia. So it makes sense that that's why it comes on. Yeah. But at the same time, they're newly independent from a social standpoint. Their peers are still not with full frontal lobes and not empathetic. So actually that's an issue, because they're probably not going to get the peer support for their conflicted things that are going on from a psychiatric standpoint. So I think that's an example of why one should stay close and stay connected to your teen. If you're a parent, don't be one of those parents where the teen flies through the house, grabs soda and a potato chip bag, and then goes up to the room and you don't see them for the rest of the night. It's a really important time and opportunity for a lot of guidance and interaction between the community and the teens.
So a wonderful book, The Teenage Brain. Thank you to Dr. Frances Jensen from University of Pennsylvania for being with us on the show today. My name is Dr. John Russell. This is ReachMD Book Club. If you would like to check out this book or other books in the series, go to reachmd.com.